Hey everybody, back with another video on these 1541 disk drive. I think on my last video I did some troubleshooting with this drive and we were able to determine that UB4 was bad. Since then I have purchased a couple of adapters from Retro Innovations, and this will adapt like a 2332 to a 2764 or 27128 or 256 or 512 probably. So anyway, I just made a quick adapter. I didn't film it or anything. I just bought the blanks. You can buy them pre-made, but I just bought some blanks because I already had some headers and some sockets and stuff. And I confirmed with the guy that I shouldn't have to do any additional jumpers here. The one thing I noticed is that in a lot of these 2764 adapters, they tie pins, I think 28, 27, 26 high on most of them, and they're not tied high on this one. So, but I was told it didn't need to work, so I just ignored that. So what I was going to do is I programmed a 2764, and I've already done this, but I just figured to highlight it real quick, and we'll put that in there and see. Actually, I'll show you what the drive does without it in first. Without that ROM in there, it'll just continue to spin and the red lights will stay on. And that was the behavior we were getting before if you watched the other video. So I'll pause, put this replacement 2764 in, and then put it in the system. I have it all plugged in. One thing is, with the socket and the standoff headers, it is pretty tall. I mean, I think it's almost up to the heatsink, or even at least to the heatsink, and plus the socket raises it up a little bit more. I might actually solder this EEPROM directly in there instead of socketing it. I don't know. Maybe not. But let's turn it on. And we have the same behavior. So I've already troubleshot this and I know what it is, but I think there's a pin, the PGM pin, that is supposed to float high, is what the guy from Retro Innovations, very nice person, responded right away to my inquiry. And what I figured I would do is I would try a different chip. So I programmed, let's see here, I programmed a Signetics 27C64A instead. And I also, what did I do? Actually, what I did first was I jumpered that pin to high, which I think is pin 27. So let me actually do that. Just to make it a little clearer, I printed this out real quick. That really shows what the adapter, this is from Jan Beta's site. So the adapter is doing these connections here from on the right hand side is the 2764, on the left hand side is the 2332. So I'm not going to go through all the pins, and I didn't write them up. But all of that's done. What is not done on the adapter is this right here, which is tying VPP to 5 volts, VPP of the 2764. The VCC obviously needs to be tied to 5 volts, and it is. And the programming voltage tied to the program pin tied to 5 volts, because it is normally, it's active low. So if it is floating low for some reason, then it thinks that the chip is in program mode. So what I did is just basically tied those two pins of the adapter, this pin right there, to this pin. Actually, I might need to tie it to that pin. Let me do that. Tie it to the 5 volts. Did I tie it to 5 volts? I'll double check, but what I'm doing is I'm tying this to 5 volts. Yeah, that's what I did. It's tied there. So we're going to put that in. Alright, so I just have it temporarily, that pin, PGM pin, the programming pin, tied high temporarily on this Intel D2764. And I'll be honest with you, I actually, because I was erasing EPROMs yesterday, I was doing this. I actually accidentally erased this, so and I had to reprogram the damn thing just to show you guys what it looked like. But anyway, now that I have that tied high, it's obviously reading the EPROM and going through that initialization. So the moral of the story is either tie the pin high. If it doesn't work, tie that pin high, or just use probably a more recent EPROM like this 27C64. So I am going to stick this 27C64 back in, and we're going to go to the next phase of this troubleshooting. All right, I guess the first thing we need to do is put a drive. Whoops. Okay, my demo test disk in here. And what I've noticed is if I turn this, well, let me turn the computer on first. What we got there? All right, and if we go to turn the disk drive on, no red light flashing, and then here we're going to type in load $. If I can, 8, and then we're going to hit return. And the stepper motor doesn't seem to be moving at all. Now, I think you can move that with your finger, maybe. It started to move. I don't know if you should do that or not, but it doesn't look like the stepper motor is moving for whatever reason. And then on the screen it just says searching for $. So what I thought I would do is there's some 1541, it's just flashing, and it says title not found, or file not found there. So what I thought I would do is I already have this VersaCart here, and I can actually, I think I have the dead test on it as well as the diagnostic test on it. So I am going to, I think Yan Beta on his site has a 1541 cart image with a whole bunch of programs on it that like includes alignment and, test, I think a stepper motor, that will move the stepper motor and stuff like that instead of typing in, manual commands. But I'm going to load it up on this in this number 3 spot. So cart number 3 on this. I think this is a 256 RAM. So I'll be right back. I'm going to put it on the tripod here and go to the burning station. Right, so the first thing is get the device in there. We're going to come up here, select our chip type. And since I already have something on the ROM itself, I'm going to read that in. Okay, buffer load from device. I guess I should turn on the thing, the programmer. Buffer load from device, and then if we hit edit, we can see where it goes from 0 down to alright, so anyway, in hex the address is 0 to 1FF, which is all the way over here, would be your first 8K, and then 2000, dang it, every time I hit my mouse wheel, right, anyway, so go to 1FF, if I use this go to address, and then we go to 2FF, I think that should be the next part. Would it be 3FF? 2FF? 1FF? Oh yeah, it should be 3FF. Go to address 3FFF. Alright, I think I have it now. Each 8K is 2000 hex. Yeah, each 800 kilobytes is 2000 hex. So you want to go to, 2000 for the start of ROM number 2, and you want to go to 4000 for the start of ROM number 3 that I'm about to burn. So let's go ahead and read it one more time. And then I'm going to save it. Just in case. Alright, and then what we want to do is we want to load a file, but we want to load it at 4000. And I think what we want to do, actually I'll just do it this way first. And then we're going to load the diagnostic cart in there. Okay, it's actually giving me the option to load it here. The offset there. Okay, and now if we view our buffer, you can see my buffer is blank at the 00, at the 0 address. And then if I go, so that would be bad if I burnt that ROM again. Actually, looks like the buffer's just empty in general. Why is that? Alright, let me see here. File, open. Alright. Buffer. Edit. Okay, there we go. Yeah, so that file, it was telling me where to load the file, what address in the file to load. It did load it into my 4000 address range, but now my buffer is empty, so that's not what we want. So because we want to be able to have the diag cart or the dead cart test, the diag test, and then this 1541 cart in there. So what I want to do now is I want to load, change my buffer offset to 0. Hit OK. Then file, open, and I'm going to open up my, let's see here, temp. Buffer, edit. Okay, this looks right. We got it. Okay, so now we're back to where we started. So we want to change our buffer offset to 4000. And what we want to do is we want to configure in our options to disable the auto clear of the buffer before file load. So we're going to do that, and then we're going to hit file, open, diagnostic cart, alright, and now if we look at our buffer and we go to 4000, we have data here now, and that should be 4,000 to what, 5FF. Yep. Then you see at the end there worldofjani.com, which is where I got this from. So anyway, now all I have to do is program the ROM, and even though the ROM is already programmed, I can reprogram it, rewrite it with the initial bytes that we're writing. We're just like writing over what's already written to begin with, and then we're writing over the FFs in the address range from starting at 4,000. So program, and should be a quick second. There we go. Verified to our buffer. And now I'll pause and we'll come back over. So instead of doing it that way, we could have just used like a Microsoft copy command on the CLI and just concatenated the files together. But I just wanted to show you how I did it real quick. And let's see, the first thing we're going to do is make sure our dead card still works. So I think, yeah, I have it ROM high and game turned on. Put that card into the, whoops, shouldn't do that when it's on. Make sure my dead card still works. I think I had it set up right. Yep, dead card still works. Okay, so we know our ROM is still good. We turn it off, take it out, and now we're going to program it for ROM low. Alright, we're going to program it for a regular cart. So we're going to put that in ROM low, and I think we want EXAROM up, EXAROM, tied high, and then we need to access the third one, the third, group of 2,000 or 8K of address space or memory or whatever. We want just address line 13 up, I think. So this should give me Jan Beta's 1541 test, if I'm not mistaken. Alright, I'm going to put it in. Bam! Worked like a charm. There's Jan Beta's diag. So what does it say? Let me take this off here. It says we can do an alignment check, disk command, directory, error scan, fast format, head exerciser. That's what I want to run, is that head exerciser or reverse knock. So can I just hit the H? Insert an empty disk into drive 8. Do that. Sorry for moving around the camera so much. I haven't figured out how to actually film all this stuff without moving the camera by hand. So let's hit head exerciser. F1 to step the track. Says F1 to step half track down up, and F2 to bump to track 1. Alright, so let's hit F2. See what happens. Nothing. I don't see that moving at all. And just to make sure that this is working, I'll power on this disk drive here, this which I know is working, and see if it does the same thing. F8 is exit. But my disk, no, my drive is just running like crazy. Alright, head exerciser. Let's just hit H for head exerciser. Oh, that's what we just did. Let's see here. Head exerciser. And then F5 and F7 turn the motor on and off. Okay, so if I hit F5 and F7 does start it and stop it. So that's F5, F7, F5. You can see it spinning. And then F7 turns it. So that's the motor. And if we hit F2, that should bump it to track 1. But my stepper motor is not doing anything. So I'm wondering if I have a stepper motor that's not working. Let's see here. What else can we do? Reverse knock. Let's hit K. Press return. Yeah, nothing. Alright, so I'm going to just film what it looks like on this one, and then I'm going to swap circuit boards and see if the problem's on the circuit board or if the problem is physical with the stepper motor itself. Alright, I have the other drive hooked up right there. Actually, let me hit stop. I'll stop it real quick. And I'm going to hit F1 and F3 to step the stepper back and forth. So if I hit F1, you can hear it and see it too. And if I hit shift, I can move it forward. So that's bumped to track 1. That's F2. And then F3 is stepping it forward. So I have complete control of the stepper motor with this program here. I'm just hitting F3 and F1 to move it backwards and forward. But I can't do that on my other drive. And then if you just hit shift F1, which is F2, it'll move it all the way back. So I think we definitely have a stepper motor problem with this drive here, and I'm going to remove the circuit board, swap circuit boards, and just see if the problem's on the circuit board. I'm not going to film doing all of this, but obviously there's all these connectors that you have to remove. So remove 1, 2, 3, 4, 5 connectors there, your AC power or your transformer power, connector there, and then it looks like probably 5 or 6 screws, and then the circuit board will come right out. And all these pins look like they're different, so or all these connectors are different, so it'll be hard for me to screw them up. So all right, I got the board off and moved over, so let's go ahead and power on. All right, go into our head exerciser. Well, we probably need to turn on our disk drive. And we're going to let's hit F2. Alright, cool. I don't have a disk in there right now. So I put a disk in. Looks like the good thing is it's something electronic, which I can fix. I can't really fix the stepper motor. I doubt it anyway. So yeah, I'm able to move it backwards and forward. So not sure what the problem is, but the stepper motor is not moving at all. Cool. If I do an exit, and we could probably do a performance test or something. You only want to do this with a disk that's blank because it's formatting the disk. But I'm going to let that run, and we'll come back and see what the results are real quick. See what the performance test is. with this board. Obviously, the test is done. Hopefully you can see it and focus it here. Basically, it formats the disks, reads and writes tracks, track 1 and track 35, and it said everything passed. So with this other board, this drive is working fine, it appears. So I need to figure out what's up with this board here. And I think when I looked at my, I have to go back and watch my other video I did, but it seemed like the timing or the clock signal, which is variable, was a little bit messed up. But I don't think that has anything to do with the stepper. It's probably some logic. I think I tested those 6522s already, and they were good. That's the only chip right there. It's not socketed, so I don't know if that's good. And maybe these two logic chips over here. So I have to do some more research. Okay, I have the original suspect board back in there with my modified ROM chip, and I have my scope on. Everything's powered up. Sorry, it's in the morning here. What I found was this, I think it's called Sam's Computer Vac or something book that has some troubleshooting information on 1541s. And it has specific steps for stepping motor being inoperative. It says typed in this command here. I think what this does is sends the header the track 1 and then the track 30 repeatedly. I think that's what that command's doing. And then it says, check for pulses on this chip here and this. Is it a VIA or a CIA or whatever? I think it's a VIA or something like that. So these two right here and then this chip, and it's telling you to check for pulses there. So I already typed in the command, as you can see there. And when we hit run, our header is going to move. Is it called the header? Whatever the heck it's called. the read head or write head or whatever. Is going to move, the stepper motor is going to move and stuff. So why don't I put it on the tripod and then we'll do some probing, I guess. First I'm just going to type in run, and you can see my stepper motor is moving, which I don't know if it's fixed or not actually, but it's going to do that until I hit the run stop key. If I press run stop here and press and hold this down, I think, there we go, I can get it to break and stop. But you can see my stepper motor was moving, so I'm wondering if there was a connectivity issue. The first thing it says to check is this P7, is it? Or P8? It says check plug P7. Oh, this must be P7 right here. Maybe that one wasn't on there real quick. Now I almost want to put a disc in and see if it works. Well, I guess maybe removing and plugging that in, because I just typed in load $sign and then list, and the damn thing worked. So now I guess I don't need to get it on the scope. Dang, that's anticlimactic. All I did is, I guess, removing that board and putting it back in, and now it's working fine. So maybe there was a connection issue here on this P7, which is actually the first thing that it says to do. Make sure P7 is in good shape right there. So I guess we don't have a problem after all. It looks like this drive is okay. Dang, I was looking forward to actually trying to troubleshoot these chips. Let me think about what I want to do next. Alright, I thought about it a little bit, and I'm going to stop this video here. Thanks, hopefully it helps somebody, but in my next video I'm actually going to will do the scope at work and everything, and show the signals and actually troubleshoot the circuit, even though I know it works. So but I'm going to stop this one here, and that's it for this video, guys. Till the next time, where I'm actually going to put the scope on these and probe this stuff. so you know how to troubleshoot this in maybe a more specific way. All right, bye.